All right. Hello, everybody. I'm Mehdi, and today we have an interesting chat about scaling DuckDB. So, thank you for joining this panel. I'm grateful to have three amazing guests. We have Jordan Tigani from MotherDuck, which is, I think, deeply involved in scaling DuckDB as a service and pushing its boundaries. And then we have also from Okta, Jake Thomas, which has hands-on experience on self-hosting DuckDB at scale and insight into real-world deployment challenges. And we have, of course, Mike Ritchie from Definite, which has also experience using DuckDB to power new architecture analytical workload. And I am Mehdi, also known as Medio online. You may see on video or on the blogs. And I'm a data engineer and developer advocate at MotherDuck. So, further ado, let's dive just with a quick roundtable of our guests. How are you feeling, everybody? Jake, you wanna start?
Yeah, sure. Thanks, Betty. Hey, everyone. Glad to be here. Really pumped and looking forward to chatting through our use cases at Okta, as well as like where we see stuff going. So, yeah.
Hey, I'm Mike Ritchie. I'm founder of Definite, and yeah, we've been using DuckDB since very early on. The idea with Definite is that we spin up a data stack for you. So it includes a data lake, and that big part of that is DuckDB. So we've been pushing the boundaries of what Duck can do, and yeah, pumped to be here. Thanks.
And I'm Jordan, as co-founder of MotherDuck. One of the things that we've sort of built our whole company around is scaling DuckDB on the server side, and also sort of the idea that maybe you didn't need some of the traditional ways of scaling databases. But I'm really looking forward to chatting with Mike and Jake.
But first, I'm a bit curious to understand about your experience. So, which version of DuckDB did you first play around? Because we seemed like DuckDB has been there for years, but actually still pretty early project on the database timeline. So, on which version did you start using DuckDB and which clients? Because I'm curious. We have statistic about usage from different clients, right? DuckDB can be used on the CLI, Python, many programming language. So, for which version and which client? Jordan, you want to start?
I don't remember the version number. I think it was like point 0.6 or point 0.7, but DuckDB first came to my attention. I think it was Mim, who is likes to tweet about data stuff, likes to try a lot of different data products. And I think he was running some benchmarks against DuckDB against a bunch of other databases. And like all of a sudden this like random embedded and analytics database is kind of holding its own against, some of the big names that had a lot of engineering effort behind them. And it's like, wow, what is this thing? And then I realized after playing with it a little bit and digging into it that there was something special there. I'm pretty sure it was version 6, point 0.6 or point 0.7. It was just about 3 years ago now.
What about you, Richie, within Mike Ritchie, within the Definite ecosystem, or was it already before?
Oh yeah, it would have been the. By the way, I respond to either Richie or Mike because there's so many dang Mikes.
I guess
Yeah.
it would have to happen. It had to
I'm
happen.
actually more likely to respond to Richie.
Okay, well, that's
It would have been 4 to 5 years. So I was actually just looking on Hacker News for the post, but it would have been about 4 to 5 years ago when it was when I first saw it there, and I guess that would have been version like 0.2, like 0.5.
oh wow.
Yeah, something like that. Yeah, I did a lot of like stock and like data analysis back in my fintech days. So yeah, DuckDB was one of the things I was playing around.
And on which client did you start to use it? Did you remember?
Python.
Python.
Yeah.
Okay.
Python.
Okay, Jake, can you beat the 0.2?
I cannot beat 0.2. I am like relatively in the similar timeline as Jordan. Like so we first chatted, I think, pre-Mother Duck. Somebody put us in touch and they're like, "Hey, we want to know your thoughts about this thing." And I sat in a coffee shop in like Beverly, Massachusetts. And I remember it well because I was like simultaneously, I had two laptops and I was simultaneously like, fiddling with like some big query scaling thing on one and talking to, Jordan and Ryan and, the early Mother Duck folks on the other. And I was like, hey, Like if their head is over here, I need to like figure this thing out and see, what this thing is. So at Okta, and fast forward, I don't know, maybe 6 months, and the first DuckDB version we started playing with at Okta was like 0.70. I remember that well. It was CLI first, and then it went, it was more of like a play thing, local discovery of data sets basically, or sharing. And then, we just stuffed it into Python and checked out what it could do, basically. And it
Yeah.
far exceeded our expectations.
And on that, we have other companies like DeepSeek. So for people who have been living in a cave, they released a large language model which was beating, OpenAI model, but also in a much cheaper infrastructure. So that's the LLM AI word. And last week, or a week and a half ago, they released Smallpond and 3FS. We're going to talk about it, which are based and using DuckDB. And so the question is, we have a couple of questions we're gonna talk about, but basically this triggered the question because people have been, as you said, Jake, starting locally, off a playground. Is like how DuckDB can scale because it's coming from a single node root origin. And I want first to ask the question, maybe to Jordan. Why do you think by default people are associating DuckDB as a single node strategy?
I think for a long time, probably the last 15 years or so, like if you wanted to be taken seriously in the database world, you had to be building distributed databases. In fact, like the CTO of my last company, he said, if you're not distributed, people will laugh at you. When we talked about actually open sourcing kind of a single node version, and so that made me think like, hey, uh, if that's the only thing stopping you is people laughing at you, maybe there's something there. And I think Hannes and Mark, the creators of DuckDB, they recognized that there was a lot of single node performance that was being left on the table, kind of since people were just everybody's focused on scale out, scale out, scale out, and kind of the dynamics, the hardware dynamics that had caused everybody to have to like scale out, build these MapReduce systems, 1,000 node systems, really didn't exist, or really have changed dramatically. Machines have gotten much better, networks have gotten better, uh, you know, larger memory sizes, more CPUs, and the workload sizes that people actually use tend to not have increased as much as the sort of the underlying, the whole data set size. Like people tend to look at only a small part of their data set. And so Hannes and Mark were like, yeah, we can build a database that can just be easier to use, and that aligns with sort of what I had been seeing. Kind of, I worked at BigQuery for 10 years. I worked at Single Store for a couple of years. Our customers, really generally operated over smaller amounts of data. Is like, hey, you can do something much more. You can do something pretty powerful if you focus on just building a great single node engine.
Yeah, and I'm curious, for example, Mike, with the definite data, is that something you can relate to regarding the size of data for the common workloads? Because I feel like what I receive from the community often is a fear of scaling DuckDB. But I feel the real question is like, what's your real size? Is that fear justified? Is this something you see within your workload?
Yeah, 100%. And I think I think the fear is probably justified. It's like, say you go all in on DuckDB and it's like, okay, your data scales, and it's like there's that very big anxiety. It's like 3 years from now, it's like, okay, is it going to keep scaling with us? You might not want to build your stack around it when there's like alternatives. And I think what we found is that the benefits just outweigh that anxiety for us, at least. And I think found it was a good 80-20, right? It's like 80% of our use cases, 80% of our customers, it works perfectly fine with just plain vanilla DuckDB. And then there might be a data set, like if there's streaming event data, or they have a really beefy Postgres database that we're replicating, it's like, okay, that might not be the best use case for DuckDB, and that's where we pull in something like Iceberg. So we have Iceberg as a storage format. We might not be necessarily using DuckDB to write to Iceberg, which you can't really do today. So we're using other processes to kind of like do a little bit of patching around the like edges. So that 20%, of use cases is where we'll, kind of leverage something else. But, the core of what we're building around is DuckDB. And in that, that core, it's like, okay, well, you can still read from Iceberg with DuckDB. So we're able to, support those use cases. So I think it's ultimately going to get us all the way there for what we need. And that's why we've gone all in on it.
You were mentioning sort of the scale anxiety that people feel. It reminds me a lot of like the range anxiety people have with like electric vehicles. It's like, well, maybe I want to go on this like long road trip that's 1,000 miles, and I think those are just they require you to change your thinking a little bit, but you can actually have a much better day-to-day experience if you are willing to make that switch.
Yeah, we've planned to visit my sister-in-law in Chicago dozens of times, and driving but obviously for context, I live in Philly, so that's a long drive, and we've never actually done it. So it's like, that was a thing that came up during car purchasing decisions, and it's never actually happened.
The fears of like the 20% you're talking, Mike, completely outweigh the simplicity and the power of the single nodes, right? Versus starting from a distributed framework from the start, but having this overhead in general, would it be for the infrastructure or the developer experience? Jake, at Okta, how did your project started? Was it also let's cover the 80%, or did you had a requirement, because we're not talking about the same size of data, I think. Did you have the requirement from the start that it need to scale?
Yeah, that's a really good question. So I'll break that into a couple pieces. The first one is like, the use case that I presented publicly and talked about, and the one that's represented here is one. Since that point, it's gone everywhere, and with many different answers to this question, but focused on that first use case. What we saw is a very inefficient workload with, basically pre-processing data as it's loaded into Snowflake, right? So copy transformation in the Snowflake world. Can you do this with Snowpipe streaming? No. Can you do this with, or efficiently with Snowpipe streaming? No. Like, it's just extremely limited. There was at the time a pretty bad small files problem. There was, all of these things that we just saw many files plus, trying to get, the minimal latency ingest into Snowflake plus, all of these other things, many sources, many different ways to pre-process or transform data. Like Snowflake is very efficient at loading Parquet, but it's not so efficient at pre-processing and ingesting TSVs and on and on and on. So I think it didn't take long. It was like maybe a month or two after the first conversation with Jordan, where it's like, oh my goodness, this tool and like this tool is absolutely perfect for removing this entire class of very inefficient workload from Snowflake, and it's can be done stateless on a file level. It can be, it's like literally the best use case to shove into a Lambda and go as wide as you need, and then as, constrained as you need, because depending on the source, it would 10,000 files would land at the same time, or, or continuously throughout the day. So, very variable workload, very hard to manage workload with many, database systems. And it was just a perfect fit. So, that's where all right, we're gonna have to rewrite this thing in, whatever, Go, Python, Rust, and throw it over here outside of the database system anyway. Why not use a database system and, therefore have, a near one-to-one mapping of like the pre-processing that was already being done in Snowflake, just like shove the SQL over here and run it highly, horizontally. So that was kind of the genesis of this. Like, quite frankly, in Data Council, I'm talking there in a month or so. we're gonna get into the remaining or
Yeah.
other use cases.
Here it's like we're taking some parts of the workload of your existing infrastructure of Snowflake, right? Um, to DuckDB. And so for people that hasn't seen the talk, so I put it in the chat on from the data console talk. But basically here the idea is to process through the lambdas as you mentioned. That's how things are scaling, right? At the file level. And so that's also another interesting way because DuckDB can live anywhere, and so it's lightweight. I guess you haven't got any problem regarding your lambda size function so far.
It's really interesting. I expected that to be a problem in like a week. I was like, there's no way this is gonna work. Like, but it was like, all right, we can test this very easily. And, and the really nice thing about that is like putting this workload on autopilot as it was before with Snowflake. Like, I don't know the file sizes. I don't like the file rates are hard to get. I don't, like you can't do much analytics on it, it being data or files as they're ingested. With this, like, we can instrument everything. The thing lands, we know the file size, we know where it lives, we know where we're going to put it, we know, we can standardize fields, we can do, a lot of, since the data is being pre-processed, we can also peek and, calculate summary metrics and drop what we need and take what we need. And, there's just a lot to it. And it,
you have a big data problem. Like as the data all gets, if the data all has to go into Snowflake, and I guess it sounds like it comes from lots of different places around the world, like that's a big data problem. But you kind of attacked it while it was still a small data problem, and you attacked it with with lots of DuckDB instances that sort of prevented you from having to deal with a big data problem.
absolutely. Yeah. And, there's a, multi-tenant versus single tenant aspect of this as well. And, happy to get into that. But yeah.
We heard about like how you scale DuckDB. Maybe Jordan, you can give a bit of word of like the vision of MotherDuck, and then we'll dive straight to the Smallpond story with DeepSeek. So Jordan, can you get us a few words about the vision and strategy of how MotherDuck scale DuckDB?
Playing on this sort of the single node, and that servers have gotten a lot bigger. Like you can get EC2 machines these days that are like the commodity EC2 machines that are 192 cores and 1.5 terabytes of RAM, and like there's not a lot of workloads that won't fit in that. That's like the equivalent hardware that's in, I think it's Snowflake 3XL, which is like $1 million a year. And then you can run lots of those. So you can run lots of those in parallel. So like the idea that servers aren't big enough anymore is sort of not true. Now there are some like fine print things that you have to worry about. But laptops are much more powerful these days. Laptops, so like sort of like Jake is doing, pushing workloads down to the edge becomes much more, kind of much more interesting and much more possible. And if you have big data, you want to operate on data where the data lives. But if you have smaller data, you can actually kind of do the computation close to where the user is, and you can really improve latency. And so, MotherDuck, we're building, scale up DuckDB as a data warehouse in the cloud.
So we have a scale up DuckDB in the cloud. We have, can distribute it to Lambda at the file level for Okta. And we have other ways. Maybe Mike, can you a bit dive? You mentioned Iceberg. Well, how that's scale? Those 20% that you were talking looks like a bit in a bit more detail.
Yeah, and theoretically, Iceberg scales infinitely, and it offers obviously dirt cheap storage on top of S3 or GCP. Pick your cloud provider. So yeah, that's what we've used for kind of the big data within our mostly small data type customers. And yeah, that's scaled extremely well for us. And one thing Jordan brought up was like local processing. If anyone hasn't checked it out, like one of the demos that really blew my mind initially, and I think DuckDB was like insanely early on this, was DuckDB WASM. And now there's some pretty good Postgres WASM clients and WebAssembly. And it was incredible. I mean, you can spin up a DuckDB shell like in your browser, and you kind of don't believe like it's running locally. Like if you turn off your internet connection, it will still work. So it's kind of a
Yeah.
nutty project, pretty amazing project.
Yeah, I put the link in the chat if people were try. It's exactly what I'm telling people during every workshop I do. If I explain DuckDB was, it's like turn off your internet connection so that you understand that nothing is running on server side. Sadly, when I'm doing online demo, I cannot do that. Otherwise, I close. So I can only do that in person, but you can do that at home. Just go to the link I put in the chat and try to play. It's running directly in the browser, running to the edge, a bit like Okta is model of like scaling to the lambdas. So we've seen multiple ways of scaling DuckDB so far. So let's dive into now the subject of attention, which is Smallpond DeepSeek project. I'll bet we have a couple of blogs because actually Mike wrote a blog. I wrote a blog. Everybody wrote a blog about it. But let's start, maybe, because I think, Jordan, you've poke around a bit the code. Say, can you do, a wrap up on what is Smallpond from DeepSeek?
It's a super interesting project, and I think they released it at the same time as their like 3FS distributed file system, which I actually think is a much more complete and probably more interesting piece of technology. But people kind of, they like, DuckDB is hot, or like the processing side is hot, and so people jump on that, and they did, come up with some pretty impressive benchmark results putting those two things together. But they're using Ray, kind of a distributed processing framework, and on top of Ray and on top of this distributed file system, they basically have a way of kind of partitioning data and then running queries on simultaneously on each partition of the data. And if you think about like in the old school MapReduce days, like, any computation could be divided up into a map, a sequence of map and reduce phases. So there's an intermediate, there's an invisible one in the middle, which is called shuffle. And so what Smallpond really is it shuffle map. Because you can partition the data, which is the shuffle, and then you map and you run, which is sort of a SQL query. And I think one of the cool things that they did was say, okay, well, for the map phase, we're going to run a whole DuckDB instance, which allows you to do a lot of really interesting things. One of the tricky parts is if you then want to combine the data again, or if you want to sort of, if you're not just going from big data to very small data in one step, it may be a little bit trickier to sort of build pipelines. But I think it's a great start, and I imagine there's going to be a lot of interesting things that are going to be built on top of that.
Jake, I'm really curious, is that something that is similar to what you folks have built? Because to wrap up, we have, the Smallpond is creating a DAG, which creating multiple DuckDB instance per partition, right? We talked that you were working at the, the file level, but I guess you work maybe also at the partition level, and you also spawn multiple DuckDB instance. Do you have, a framework around that to trigger those lambdas? And that looks a bit like Smallpond. Like, what's your feeling about this?
Yeah, a couple things there. So first, for a while, there was no complexity needed. Like, it was just so dead simple. We wanted to see how far we could run with it. And it was, very, very, almost stupid simple from the like read side. It was more complicated and interesting from the like, how do we keep the system up and running and change our, SQL transforms, basically, like config management system, and, basically loading config as a thing came in, and what do I do with it? Where does it go? What do I, what is it? What do I do with it? Where does it go? And, what should I scrape for metrics effectively? Right. That is like dead simple. But the exploration prompted a lot more of like, okay, let's look at our customers, let's look at our workloads, and let's look at what we need to do. So those three things: customer perspective, and this is something I ran into Shopify and the robotics world there. Same exact problem, right? If you scope all of the data for any single customer Can I use DuckDB only? Yes, absolutely, easily. Can I do most of the processing in a Lambda? Yup. For the stuff that I can't do for a single customer, can I do it with some other piece of hardware? Absolutely. Like I can literally run like the largest customer at Okta's workloads on my laptop, my work laptop, which isn't, by no means a M3 Ultra or whatever, right? Like it's pretty basic Mac. Let's look at the customers, let's look at the workloads, and let's look at what we need to do. There is a lot you can do when you scope to a single customer. Now, analytical workloads across all customers, like those are usually where I have historically started in the analytics world, like put all the customers together, right? And then I shoot myself in the feet building data products and all this stuff because now I need to partition by customer or, split it out by customer because the ACLs need to be maintained and on and on. But like all of those workloads, if you put closer to the customer infrastructure, if you put closer to the customer and then shard them by customer, you can do a lot. And then, you get into the like federated query across the customers, but like the partitioning's already there. It's already natural. Like I've shot myself in the feet so many times for like being unnatural with how I stuff data in a pile.
That's interesting, the breakdown approach. And I think that's the biggest challenge that we have with DuckDB is that we have to kind of think and reason that way, right? You mentioned, okay, can I run it per customer, right? That's smart sharding, and I don't need more complexity. And I think this is the reasoning that you need, which is not always obvious if you have a service, a data processing framework that's scaled by default, where you don't need to think about those, breakdown things. So I think that's definitely interesting. Coming back to Smallpond, so regarding their approach, we have Mike. You worked in the blog. Is Smallpond for me? And the TLDR is probably not, because we are talking. So Jacob mentioned the stats that were impressive. We have 3.6 terabyte per minute in throughput for sorting, which is enormous. So do you think actually we need this kind of setup and distributed DuckDB?
So yeah, I think like that was the main thing I wanted to dig into, because like I was also asking for myself, is like, is DuckDB for us, or is Smallpond for us, right? Like, is this something that's going to actually be valuable for definite? And the answer for us is definitely not. A lot of the approaches are interesting, very interesting technology, but I always think a lot about like motives, especially when like a company's putting out something like this. And when you think about DeepSeek, what are their motives? Like, how are they using Smallpond? And it's so different, if you really think about it, than how most of you are using like DuckDB. And the way that, and again, they don't release this in the GitHub repo, but if you really think about it, how they're probably using Smallpond is to parse massive amounts of like text data that's being fed into training. So they might be loading like individual web pages as like columns, or rows in a database, and then using some DuckDB functionality to like filter out duplicates, like duplicate text pages, or kind of chunking the data down to a certain degree and chunking out that way, or filtering rows out that way. So that's the type of workload I think they're probably running on Smallpond, which is like just radically different than what most of us use DuckDB for, which is like analytics. So it's very unlikely they were putting like Power BI dashboards on top of like DuckDB or doing any sort of like dashboarding analytics with this. It was like a very kind of different use case, and that's that was the TLDR that I came up with, is like it's probably probably not for us, and probably not for a lot of like analytics folks, but extremely interesting ideas.
Jordan, you've been diving into the Redshift, data report usage. So just as a quick reminder, Redshift, shared the people's workloads on the AWS Redshift. If you're not aware, it's also a data warehouse in the cloud from AWS. And the TLDR is that 90% are below 1 terabyte and 10 terabyte range. I think it's huge. And so the question is here, like Smallpond is sharing huge amounts of number, right? And Mike just mentioned, like, I don't think it's typical analytical workload. So we cannot really refer to this, Redshift report to say, okay, that's actually not those 10%. Do you think DuckDB is bridging into other use case area, and what's kind of population it's targeting 10 Smallpond for this?
And actually, one like big thing I missed in that the use case, I believe that Smallpond only works on a single table too. So it's like if you want to
Yeah.
run a join, which a lot of your analytics are going to need, it already kind of falls apart at that point.
Well, you mentioned this sort of red set data set, and Snowflake actually had released another similar data set a couple of years early. And we did some analysis on it, but we're biased. But George Fraser from Fivetran also did some analysis on it and basically showed that the vast majority of workloads don't need don't operate over a lot of data. And I think the one that you were mentioning was like most databases themselves are not even that large. Certainly people do, and we talked to lots of folks who like, well, I agree that big data is dead, but I've got big data. And, it turns out that the majority of the time, what they have is kind of deeply partitionable data. Like Jake was saying that the majority of the work that you do is sort of within a partition, either whether it's in a single customer partition or it's within the most recent date ranges. And, I think and that's an area actually where the data lake can allow DuckDB to scale much better because, as Mike was saying, if your data is an iceberg scales virtually infinitely. And if what you're looking at can be kind of trivially filtered from like a well-partitioned iceberg, reasonable database is pretty good at recognizing that, hey, I don't actually need to open up and scan every single one of these files. I can look at just this partition, or I can look at, hey, there's a filter on this thing and this file doesn't have anything, and that's why I have to look at that. Then that's also can enable something like DuckDB to scale much better because you're actually only having to inspect a small portion of that data. So I also think that like one of the biggest opportunities is DuckDB over a data lake, because like the computational power that you need is single node can fit in a reasonable size. The data set might be big, but as long as you're looking at like in general, people only look at recent data or one customer's data, because otherwise it's too expensive. Like in BigQuery we used to say, hey, we can let you scan this petabyte in like in a few seconds. But if you look at how much that cost to do that, it was like a $10,000 query, and you don't want to run that all the time. I mean, like Google wants you to run that all the time, but like most people don't have the budgets to run that, and so you do things more in a smaller scale, more where you can be more efficient.
Yeah, you at least don't run those queries all the time on purpose. We've definitely reached out to. I've been guilty of reaching out to BigQuery support. Like, whoops, like that was $2,000. Can we get that one back?
Basically, you can scale your storage to data lake, but you don't really need to scale your compute because you mostly need to compute fresh data, which by the way is a bit fresh. But regarding the use case and the number of Smallponds, Jake, what's your thoughts on that? Do you think it falls into analytical workload, or is it more AI specific, as Mike mentioned, with like text processing?
Or several things in my mind there. So just like Jordan was talking about, like all big data problems become small data problems if you attack them at the right point. And, sometimes they're obfuscated and they're part of, a physical plan in the database that you don't see. But like the deployment flexibility of DuckDB allows like an unbundling of a physical plan to some degree and allows you to attack the problem way over here where historically it's been, within your data warehouse or whatever. So, with respect to the Smallpond topic, I've seen it framed, bringing distributed compute to DuckDB or whatever, right? But in my mind, it's like literally the opposite. It's like bringing DuckDB into a distributed systems problem, and like I think, no pun intended, like I think what we're seeing here is like the tip of a much larger iceberg, where DuckDB can be brought into many distributed problems, or many, deployment problems, or many jurisdictional problems or many compliance problems where like I can take a DuckDB and throw it in a existing set of infrastructure in IL6 environments tomorrow, and like I don't have to do anything like except get it there. I don't have to get an SCR. I don't have to get all kinds of other governmental approval. I can just do it, and that is like very, very
Is that
powerful.
it does give you this like superpower that you can kind of staple a DuckDB to anything. But the other thing, on the other hand, like once you sort of, if you go outside that box of things that work really well, sometimes it becomes very, very difficult. Like as Mike was saying, like with Smallpond, like you can't do joins. Like it's like, okay, well, it seems like it would be sort of obvious or easy. Like why does you like? But like on the other hand, like it it makes this sort of really hard thing seem easy, and then sometimes things that seem like they should be very, very similar become difficult. Is that something that you've encountered?
Yeah, I think there's no question about it. Like the trade-off has to be acknowledged. And, it is not general purpose. It's like these very domain centric, without the supporting infrastructure or without the supporting things that, say MotherDuck is building. So it's easy. Uh, you know, uh, what is currently easy becomes hard in some cases. But what's currently impossible becomes possible.
I think one of those like usually easy things is, Postgres. If you start up a Postgres instance on AWS, it's like, okay, I can connect to it from anywhere in the world now with like, and I expect that like right out of the box in AWS, Redshift, or not necessarily Redshift, but Postgres instance. And it's like that's not really a DuckDB thing. Like you don't, there, aside from obviously MotherDuck with Jordan, it's like the one that you're running locally is not terribly easy to host and then connect to from a bunch of different processes externally. So that's still something that requires a good amount of DevOps and just experience doing that sort of thing.
What is the biggest I think challenge and pain, Mike, while you are at it on self-hosting DuckDB you've seen?
Yeah, I think it is. So managing multiple writers is certainly a thing, and having near real time writes into, so kind of like streaming updates into DuckDB. I'd say those are our two biggest challenges, and we've evolved our workarounds. So our initial workaround to our current workaround for that is a bit different. We actually wrote a blog post on one of the workarounds we've been exploring, which is using Aeroflight. So that's an extremely interesting bit of technologies, kind of using Flight and DuckDB in conjunction to kind of solve part of that problem. But that's currently, our biggest challenges, and I'd love to hear Jordan's as well.
One interesting thing though is like if you start to work around limitations in DuckDB, often by the next release of DuckDB, like you don't need that workaround anymore, and you're like, oh, I just built all this cruft, and now I don't need this. Now I don't need this cruft, and sort of I've architected, in this way, and I don't need that anymore. And that's one of the nice things that we work really closely with the DuckDB team. So we sometimes we can avoid kind of going too far out of our way. But there are certainly things, as you mentioned, like the multiple writer things, low latency writes. Like, so we have been working with the DuckDB team on improved writes, improved latency. There still is the sort of only one process can write, can have the database open for write at a time. There's other things like concurrence, read concurrency can be difficult, and those are things that we've worked around. We've worked like similar to you, Mike, and we've worked around those in different ways. Like we can spin up multiple replicas to be able to scale out reads. We can kind of sort of transparently funnel multiple writes to the same location, and and DuckDB does keep getting better and always keeps us on our toes.
But that was one of the reasons I was so excited to hear at the last DuckCon, where they mentioned like 2025 is going to be the year of the data lake, or the year of DuckDB on top of the data lake, because a lot of those problems are already solved in a data lake. So there's already good concurrent write support in Iceberg. Obviously, we've been talking a lot about partitioning. You can partition your data by day, by hour, whatever it makes sense in Iceberg. And instead of reading thousands and thousands of Parquet files in from your data lake, you can read in 17 or whatever you need to actually complete the analysis. So really excited to see what the Duck Labs team comes up with there.
Jack, is that those limitation resonate with you, like multiple write or low latency write, or is this something because you're already sharded by customer, you were not impacted that much?
Yeah, no. So in the original use case, like not necessarily a problem because it's like ripping data out of S3 and putting it back into S3, right? With that being said, uh, for other use cases, no question, 100%. As Mike mentioned, tapping into Arrow helps. Fully wrapping helps.
The long story short is that self-hosting DuckDB is pretty easy depending on your use case and how you break down the problem, right? If it's per partition or per customer like yours, and you don't need specifically join, that's okay. Things start to be a bit more, difficult as your business, I would say, use case and analytical workloads need specific joins. There you need to do specific ops and extra work. And that's what also MotherDuck building we're working on. Coming back to the DeepSeek, but 3FS. So we talked about data lake, and a lot of workload I've seen so far are, have a strategy on AWS S3 or, equivalent Azure or Google Cloud Storage. How do you think the 3FS is fitting that, landscape of data lake or not? Or maybe it's a really specific workload, Jordan?
I think it's a high performance distributed file system, and I think it's sort of an update, I guess, of like HDFS. I think it's a read write, fully read write, like not like an object store. Object store basically, data becomes immutable once you close the file, and so that does have some limitations. But I would imagine. I mean, I think also like because if you're running it on any hardware, you're using RDMA to sort of to be able to move data around. I think it's just a very, very high performance system that would be hard to build on a cloud, because RDMA is not available in the cloud unless you're the cloud provider themselves. Like I know they do a bunch of those kinds of things under the covers. BigQuery used to use RDMA for shuffles, for example. And I think the other thing is, you can get much faster disks than you can get on AWS. If you're willing to sort of buy and configure your own hardware. And so I think that's what DeepSeek has done is they said, hey, we want the best performance. And so the best performance isn't really available in cloud machines that you can just spin up on EC2. And so they kind of configured this, and they built an awesome low latency distributed file system. And I think that, is a lot, to a large extent, what has enabled them to get such really good performance. And, and I think if you're doing training and, you have a bunch of GPUs and the GPUs are waiting for IO, you're wasting money. And so it makes sense to spend money on building this kind of hardware.
Not obvious to set it up yourself. That's the deal. Especially if cloud research doesn't have RDMA network available by default, which is a requirement. Mike, is that something that resonates with you when after your first thoughts on 3FS?
Yeah, one of the first things that I used ChatGPT's deep research on was cloud file systems, because that's one of the things that we obviously leverage inside of our product, and would love to find alternatives for, because Google's version of it, called I think it's called File Store, is insanely expensive, and Amazon's isn't too much better EFS. So did probably one of the nerdiest deep research use cases was researching different file systems that are available in cloud services. And I think the punchline with 3FS is like, no, it would not be easy to spin this up. And I don't think possible, to Jordan's point, to spin this up on AWS, even if you were like a cracked, DevOps engineer. Like I just don't think it's possible based on the permissions that you'd have available to yourself. So you'd have to, buy your own metal.
Yeah, given that you're cracking DevOps at Okta, do you think it's like also something you resonate to, or did you actually see some limitation in AWS S3? I guess it's your main storage, right? Correct me if I'm wrong. Over there.
Yeah, I mean, there's nothing that I could say that is much beyond pre-existing research on like why or why not to use S3 to back databases. There's all kinds of really good research papers. One thing that the most interesting thing to me, or the fun part about this, is like seeing it for yourself. Basically running this like research project in production that has all kinds of commercial production benefits, but also like seeing exactly what people are talking about in those research papers, and getting to experience and explore that firsthand. So yes, limitations are there, like without question. And 3FS to me is like very interesting, especially because it represents more of a workload cost management thing. Like honestly, in more and more use cases, especially with systems like DuckDB, like setting up your own hardware actually looks pretty attractive because you can control cost, you can use it, you can saturate it, you can do all this stuff. So looking to the future, like it's really interesting to see these things colliding from my perspective.
Jordan, owning your own hardware for saturating DuckDB, how do you feel about that?
I feel like it was a couple of years ago, there was like this trend where everybody was people were moving out of the cloud and building their own hardware. And I feel like that trend may be reversing. You certainly don't hear about it quite as much anymore. Like it seems reasonable, and then you have these like, and then you realize, okay, now I have like 2-year-old hardware and 3-year-old hardware, and what do I do with it? And things are failing. I know it when I was my last job at Single Store, we had our own. I think it was like $1 million worth of hardware in a data center that saved us several $1 million in AWS costs because we just ran like these continuous tests on it. On the other hand, it was like after a while, it was just a pain to update. And it's like, oh well, the person who used to go in and like rack servers, left the company. What do we do now? Like, where is this? How do I do things? How do I connect things? Oh, and we have all these servers that are like dead and they just are turned off. And like, so yes, if your goal is to squeeze the absolute most performance or price performance out of things, then then yeah, it can be reasonable. But I think, for the most part, if you just like, hey, I have a job to do, I want to get it done, and I don't want to do a lot of work to get it, is probably not for most people. There are other interesting clouds like, fly.io, and like, folks that can kind of do some interesting things, give you access to some different hardware and sort of closer to users that are also sort of also interesting.
So yeah, it's a good point to as a reminder that we're talking about different size of teams here, probably. Jake, can you maybe just a quick reminder, like what's the size of your current team and size of Okta?
Is Okta, I think right now is like 7,000 people. My team is 10 formally and growing very quickly. So it'll 2.5x that pretty soon.
Mike, what kind of like data size team usually your product is targeting?
Company, we're in the kind of 50 to 500-ish range, like, and I'm anywhere in there. Like usually below 50, they don't have the need for data products in general, and then above 500, they usually have already established a lot of the components that we offer kind of as part of a package. So that's kind of our sweet spot.
Yeah, I think that's a good numbers. Like what I've seen also based on my experience is that if you're in a company above 500, and then it's depend also on your data data team size, because sometimes it doesn't grow linearly, sidely. But if you're above 500, then you can consider those things of, self-hosting and managing things. Below that, that's probably going to be, an overhead for you. And I think there is also good times, to move from serverless or hosted things and to your own thing. As Jordan mentioned, we've seen that in the past. It's happening less for some reason. But yeah, that's an interesting point. We are getting close already to the talk. It's went super fast because you had all interesting insight. What to close up? I would like to ask you, what do you think you've seen? We've talked a bit about data lake and Smallpond, but aside from that, what's for you the most exciting thing about the future in data with DuckDB? Jake, you wanna start?
Putting databases in hardware. Yep. So OLAP capabilities following what SQLite has done.
Yeah, and one thing that has me extremely excited is I think DuckDB is the first OLAP, like open source OLAP, that has like pretty heavy adoption. And I just dropped a link to an one of our first open source projects as a company. It's a transformation library written for specifically for DuckDB and written primarily in Rust. And I think the ecosystem that's around DuckDB is the thing that has me most excited. Like Jordan mentioned, every release, it's solving problems that we were previously solving in a really ugly way. So like, I think that's the thing that just has me the most excited is like the ecosystem around it. And then obviously you see something like Smallpond be released, like not ideal for analytics, but still like extremely interesting that DuckDB is being used in projects like that.
Jordan, what about you? You're excited, I know, by a lot of things around DuckDB itself, but if you can be specifics.
I think I think if more people are moving to data lakes and they're moving to like open data formats, I think as DuckDB gets better at these open data formats, these sort of DuckDB based query engines over your data lakes are going to be incredibly powerful, and I think we're going to see just sort of a ton of adoption because it's just going to be easier to use and less expensive than almost anything else that you're likely doing, and probably faster as well.
Yeah, I think that's a good conclusion because we talked about 3 different ways of scaling DuckDB as the first part of the discussion, and then we also discuss about how data lake can help scales your data size, but not the compute, because you don't necessarily need to scale the compute if you break down the problem and you process fresh data mostly. So that's an interesting ways of going forward of enabling more possibilities to scale DuckDB. But those open data format, let's be real, there have been a lot of movement, right? Political movement influencing, I feel, those projects with the acquisition from Databricks. And so we have Iceberg, Delta Lake, and I think it's also honest to recognize that those projects are moving, and basically DuckDB are also depending on the maturity of those projects. But I guess exactly as you said, Jordan, as those projects get mature, then DuckDB can follow some adoption pattern. Thank
Don't forget to
you very much.
throw Xtable in the mix now.
Oh yeah, if I talked about Hoodie and Xtable and others, one rule demo framework, where something will never end. Thank you very much, Jake, Mike, and Jordan for joining this discussion. The recording will be available on our YouTube channel. If you have any question, you can, of course, we can continue the conversation on the MotherDuck Slack, slack.motherduck.com, or you can, email us at quack@motherduck.com if you have any random question that we haven't covered within the chat. And on that, I'll say thank you, everybody, and have a great week.
Thank you.
Yeah, everyone.